Okay, on this example, it says a lighthouse is on an island 450 meters offshore. The lighthouse beam makes a full turn every 13 seconds. How rapidly is the point where the beam meets the shoreline moving along the shoreline when the beam meets the shoreline at a point 1,400 meters from the lighthouse? Assume that the shoreline is a straight line. All right. First up, we need a picture of this situation. So, okay. So I'm gonna do the shoreline. Here we go. That's the shoreline. It's a line. As they said, assume it's a straight line. Okay. And then we've got some kind of lighthouse is on an island 450 meters offshore. So there'd be some kind of, let's say, lighthouse here. This will be the lighthouse. So that's one word. Lighthouse. Okay. So now what happens? Well, they said it's 450 meters offshore. So what does that mean? That means the line from here to here that goes at 90 degrees is 450 meters. Now you might wonder, how'd you know that was the right angle? Well, that's excuse me, that's what it means to be 450 meters away from something. Like if I said, here's the shoreline and the lighthouse is out here on an island, 450 meters off the shore. Um, that means if you go from the lighthouse to the shoreline, you don't go like at some angle, right? It means straight at it. Whenever we talk about the distance between a point and a line, the lighthouse is a point, the shoreline is a line. It's always the straight distance, right at 90 degrees, straight at it, not some other longer distance, at some angle. Because, so that's what it means. So the distance something is away, it means at 90 degrees. That's just what it means to talk about distance. Okay. And the beam, it's going around and it's moving, right? The light beam is moving like that, and there's some angle theta here. The light beam is moving that direction. I don't know if it's right or left, we'll just say that way, as the thing turns around. The light, runs along the shore, right? As the light beam spins around. The lighthouse beam makes a full turn every 13 seconds. Okay. So there's our picture. So step one, you remember step one. It's always um, identify identify all the rate letters. Okay. So what are those? Well, the beam makes a full turn every 13 seconds. So that's d theta dt. That's how fast the angle changes over time. That's what? One full turn every, check it out a little better, every 13 seconds. Right? That's the change in angle over time. But actually, full turn, what's a full turn? Well, we could say that's 360 degrees every 13 seconds because a full turn, like all the way around, is 300, right? You start here and you go all the way around, that's 360 degrees. But we can't leave that in degrees, huh? We have to do it in radians. So instead, here, let me do this better. 2 pi radians. Do you remember how here I could put in a little unit circle, maybe it'd be helpful. Here we go. Stick one in, well, maybe that room. Um, yeah, let's put it like this. There we go. Here's a little unit circle. Here, let me crop that a little better. Just get rid of the edges there. So I should have had that all ready to go. All right, there we go. There's a little unit circle. Good enough. Okay, so yeah, on a unit circle, this is what I give to my trig students. Feel free to use this. Put it down in the exam if you need it. But really, 0 all the way around is 2 pi. 2 pi radians is the same as 360 degrees. That's really all we need. So, so remember, you have to be in radians when you take the derivative of sine or cosine or tangent, any of those, you must be in radians. Must be in radians because the derivative of sine is cosine and cosine is negative sine only in radians. None of the derivative rules we've learned work in degrees. They only work in radians. So got to do 2 pi radians. That's all the way around every 13 seconds. So there we go. So anyway, there's d theta t. What other rate do they mention? Well, it actually asks for another rate. It says right here, how rapidly is the point where the beam meets the shoreline moving along the shoreline? So, okay. So let's call this x. And they're wondering how fast is that where the light beam is hitting the shoreline? How fast is that moving along the shoreline? In other words, they want to know what is dx dt. How fast does x change over time? X being the distance from straight to wherever the light beam is right now. How fast is that changing? That's what they want to know. So identify the two rate variables. Step 2, write an equation relating, these related rates, relating those letters only. And numbers are fine. So in this case, it's theta and x. So no other letters, just theta and x. Those letters only. So I need some relationship with theta and x only. So, oh, wait. Yeah, no, we're good. We're good. How we can do that? Well, you probably remember some of this stuff. This side is the side opposite theta. This side here is the hypotenuse. That makes this side the adjacent. Remember how that works from your trig days? So from the angle theta's perspective, the side opposite, that's x, the side across from the right angle is hypotenuse, the other side is adjacent. So we're going to use SOHCAHTOA. Remember SOHCAHTOA? SOHCAHTOA. And a lot of students ask me, "Mr. how do you know whether you use sine, cosine, or tangent?" Well, I just look at the sides I have and need. I want to find out x. I already have the 450. I don't know anything about the hypotenuse. So I want to use the opposite and adjacent. Does that make sense? Because I want to find x. That's what the question is all about, dx dt. And I know this side. So take what you want and what you know, and that's opposite and adjacent. Which trig function uses opposite and adjacent? Well, tangent. So there we go. Okay. So it's tangent of that angle theta equals opposite over adjacent, x over 450. That's opposite over adjacent. Okay, so there it is. And that has only x and theta in it. So that's an equation relating those letters only. Beautiful. All righty then. Step 3. d dt, both sides. So now I'm going to take that equation. I'm going to go d dt of tangent theta. And then d dt. Oh, I'm going to rewrite that. We don't like fractions. Oh, we don't like fractions that have an x in them, I should say. Like that, right? So that's a quick little rewrite. You know what I mean? You might say, well, it's still a fraction. We talk about, well, now it's just a fraction with numbers only. Right here, it was a fraction with x in it. If you're going to take the derivative of a fraction with x, and you got to use the quotient rule. I don't want to use the quotient rule. So instead, I pull the fraction to the front, and there's just a plain x now. All right, let's take the derivative. How do we take the derivative? What's the derivative of tangent secant squared of theta times, since the inside is not a simple t, take the derivative of the inside, which is d theta dt equals. Now the other one, the 1 over 450, just sits in the front, and then it's dx dt, like that. Okay. So I'm gonna try to solve now. And so step four is plug in the numbers. Now, what numbers? Well, whatever theta is, whatever d theta dt is, and we're trying to find dx dt, right? So, first, so do I know theta? No, they never told me theta, did they? What else? What other numbers did they give me? This right here. Um, how rapidly is the point where the beam meets the shoreline moving along the shoreline? When the beam meets the shoreline at a point 1,400 meters from the lighthouse. When the beam meets the shoreline at a point 14 meters from the lighthouse. So they mean this is 1,400, from the lighthouse to that point, right? It says, when the beam meets the shoreline, this is where the beam meets the shoreline right here, at a point 1,400 meters from the lighthouse. This is 1,400. That's what they're telling me. Okay, great. Well, that's going to help me find theta. And you say, well, how's that going to help you find theta? Well, see how I've got these two numbers? This is what? Adjacent and hypotenuse. What trig relationship uses adjacent and hypotenuse? Oh, now we're switching to cosine. Cosine uses adjacent and hypotenuse. So that means the cosine of theta is this over that. Yeah. So that's probably a little tricky here. So what we're saying, the cosine of theta is the adjacent of the hypotenuse, which is 450 over 1,400. It's adjacent over hypotenuse. Now again, why did I choose cosine here? Well, because they told me this is 1,400, that's hypotenuse. I know this is for you. Why don't you use the x? Well, I'm not trying to use x right now. I'm trying to get numbers, right? I'm on step four. I just want to plug in numbers. I don't want any x's. I want numbers. So these are the two numbers I have. That's adjacent and hypotenuse. And so that's cosine. So cosine of theta is adjacent over hypotenuse. Okay. Okay, yeah, great. So what? Well, then um, I'm going to come in here and go, oh, you know what I can do? Oh, I got it. You can rewrite this, huh? This is going to be um, 1 over cosine squared theta times d theta dt equals 1 over 450 dx dt. See what I did? I rewrote that secant squared as 1 over cosine squared. Do you remember that from the trig relationships? I'll just write it out real quick. Sine, cosine, tangent. Remember that? And then when you flip them, flip them, flip them. If you flip, upside down, remember this much in trig? Put this on your note card if you need it. Cosecant, secant, cotan. So the cosine is the flip or the upside down of secant. When you have secant squared upside down, and that is that is equal to 1 over cosine squared, right? Flip to the bottom. Same thing. Okay, great. So what now? Well, now we can plug in because I know the cosine is 450 over 1,400. So then this is gonna be, what's it gonna be? It's gonna be 1 over um 450 over 1,400 squared. This is cosine squared. And cosine is 450 over 1,400 times, and then what's d theta dt? I think we have that up here, don't we? Oh yeah, right here. This is, so d theta dt is 2 pi over 13. So that's going to be 2 pi over 13. So there's that. And I'm going to say equal 1 over 450 dx dt. We're trying to solve for dx dt, right? It's trying to get alone. So this is our unknown right here. So, okay, so multiply, you got to get rid of that 450. So last step, multiply both sides by 450 over 1. It'll cancel out here. And 450 over 1 here. So I just multiplied 450 over 1 on both sides. Canceled that out. I don't need to be that scribbly, I guess. And so now we have dx dt alone. And what is it? I'm just going to put this on the top up here. It's like a nice little fraction out of this guy here. It's going to be 450 times 2 pi over 450 over 1400 squared times 13. You can just stick that 13 in the bottom. You know, right? This just goes to the top, this just goes to the bottom. Or you could just type all this in. That's fine, whatever. I'll just go type that in now. 450 times 2 pi. Let's go to Desmos. So, so this fraction. Oh, I believe that. Wait, we're gonna get totally messed up here. Oh, that's right. Over 2 pi. Oh, I don't remember where we're at. 450 over 2 pi, is that right? Let me go back. Oh no, 450 times 2 pi over 450 over 1400. Okay. Oh boy. Times 2 pi over parentheses 450. Oops. Okay, come on. 450 over. What is it? I can't remember already. 450 over 1400 squared times 13 over 1400 squared times 13. I think I've got it right. So 452 pi, 450 over 1400 squared times 13. Yeah, that looks like it. What do we got? 2105. 2105. Is that right? Is that the answer they're getting? Oh, yeah, that's beautiful. 2105 with some change meters per second. And so there we go. That's how we do that one.